Hey there, 7th grade. Welcome to the second section on this. We're going to be talking about section 612. We're going to kind of continue a little bit more with the algebra tiles. Again, I strongly recommend you use the ebook and access your Chromebook on these because it's going to be way easier than trying to draw and or visualize all of these. So this section is talking about what if you cannot tell what the value of this is? What if you don't know the value of the variable, and if so, then how do you represent that knowledge? So if you don't know the answer to something, how do you mathematically say that you don't know the answer to it? That's basically what we're leading up to. Also, the other thing that I want to talk about is these skills that you're using with these expression mats, where you will access it and you're removing things from both sides or you're adding things to both sides. You absolutely need to be comfortable with the fact that this keeps things the same. What I want you to understand is that these actions that you're doing here, where you are adding or removing from both sides, is something that you will continue to use later on. You're going to be using a lot of this in 8th grade. So I want to start with this first one where it says, determine which side is bigger. And we're going to look over this. If you've got these two expression mats, there were a few different what we call legal moves, where you can take something where you say, okay, I've got a negative x on one side and I've got a negative x on the other side. I can remove them both and it will keep it balanced. You could also say I've got a negative x on this side and a positive x on this side. So in this visual example, this is my negative x and a positive x, and say, okay, well, I'm going to take both of those things, the negative and the positive x together, and I'm going to just remove them from my problem. Because I can do that. Because this is just another way of representing 0. It's just nothing. Now, again, same idea. You've got a negative x on the one side, and then you've got a negative x on the other side. I can take those two values and say, well, I can remove these from this expression without unbalancing it, without changing the fact that these are still balanced. So you can remove both of those. You can continue doing this as long as there are what we call legal moves. The negatives can go away. These two can go away because they make a 0. These two make 0. And you can do it in whichever order you want. You say, well, I've got two positive ones here. I've also got two negative ones here. Leaving me with the left side, which is 4, and the right side, which is 0, so the left side is clearly bigger. Something odd's going to happen when you start getting into these problems. If I try to use what are called my legal moves, I say, well, okay, I've got an x on each side. I can get rid of the positive and negative 1. I can get rid of those. And all of a sudden, you're left with this statement where you're like, well, I don't know which side is supposed to be bigger. I don't know which one is supposed to be bigger than this because I don't know what x is. So that's what this section is going to talk about, is the fact that you can't always determine which side is going to be bigger because of the certain values. Again, I would like you to try doing a couple of these. Just grab the student e-tool off of this and build the expression. Most of it's done for you if you click on these. You can just click on the student e-tool and then just practice. Group them up. Grab the positives, grab the negatives, remove them, and then see if you can get the right expressions. These are sort of a overview of different moves, and some of them are legal and some of them are not. You are allowed to put the whatever number you want on both sides. So you could take each of these 4 things and look at, well, which ones am I allowed to do? Okay. Am I allowed to add -3 or +3 to both sides? The answer is yes, you can totally do that. If you do something to one side, you have to do it to the other to keep these things balanced. So this is a -3 and this is a -3, so that's fine. It did not imbalance the equation at all. This one does not work. You cannot add different numbers to both sides. it would be like saying, well, I know that 3 is equal to 3, but I'm going to add 3 to this, and I'm going to subtract 3 to this, and then I'm going to say that 6 is equal to 0. You're not allowed to do that. You cannot just change the numbers like that. Similarly, on this bottom one, which kind of cut off a little bit, you can't remove different tiles from different sides. Okay, so that is also a no-no. On the last one, you are allowed to do this where you added 3 positives and 3 negatives, because it's the same thing as adding 0. So if I had, again, let's go with 3 equals 3. If I added 3 to that side and subtracted 3, well, I know that that's just 0, so it didn't change my expression any. So these are just a few things to sort of talk about with the legal moves. Again, I want you to practice these, and again, if possible, decide which of the expressions is bigger. Quick homework review: if you get something where there's x's left and you don't know if it's bigger or not, then the x's are going to control that. 6-18 on your homework for this one, what I did is I drew the rectangle for you. On this rectangle, what you're able to do is fill in the blanks on the top and the sides, and you're going to find a relationship, and then you're trying to guess and use the 5D process to figure out what those lengths are. On 6-19, order of operations is one of those things that people are going to continue to mess up until the end of time. I get it. I understand that. So every time you're doing a problem like this, you are operating under PEMDAS. Please excuse my dear Aunt Sally, which I don't really like the M and the D being separate like that, but they're together. So you always look at, let's look at this first one in part B. Is there any math inside of parentheses that needs to happen? Yes, there are parentheses. Great, let's look in there. Are there exponents in there? No. Is there multiplication? Yes. Let's do the 4 times 2 to get 8. Hey, is there still math to do? Yes, 6 plus 8 is 14. That's inside the parentheses. And now you're left with this problem that is -3 times 14. So just keep that in mind. Whenever you're doing these, you have to be super careful. Make sure that in something like the 5 squared in this first one, you have to do that first. These ones are going to be weird. You're writing an expression in 2 ways, one of which with parentheses and one of which without. So a number reduced by 3, anytime you see the phrase a number, that stands for x. Reduced by 3 means you do -3. And then it says multiplied by 2. That means the entire expression is multiplied by 2. And you might be thinking, okay, well, where am I going to get the other expression for this? How did they take an expression with parentheses and get the other one? The answer is using the distributive property, which involves taking this expression and multiplying it through. 2 times x. 2 times x is 2x. Multiply through. 2 times -3 is -6. So these would be my 2 expressions that you're writing for this. One is 2x minus 3. The other one is 2 parentheses x minus 3. The other one is 2x minus 6. So try doing these with all of those and see what happens. If you can't graph this on the paper, that's fine. Do your best. And for the percentage one, if you are trying to find out a tip, if you have 15%, then you do take the 15%, and you are going to convert that into 0.15, and then you will multiply that by the 27.38. Okay. I hope this has been helpful for you guys. Good luck, and let me know if you need help during office hours.